Hey everyone, this is Mr. Munson. We are on Unit 8 Quadrilaterals. This section, called 8.4, is about trapezoids and kites. This video is dedicated to Darwin, who absolutely loves steak. Feel free to pause the video and just stare at the incredible, delectable piece of food art. When you are ready, press play and move on.
Okay, so one of your ICANN statements is that you can identify the properties of trapezoids. So we're going to need to make sure that you understand some of the, the properties, but also the words that we're going to use when we're talking about trapezoids. So for one of them is that we're going to be talking about legs of these things. And so when you're looking at trapezoids, the legs are the two non-parallel sides. And then the base angles are two specific angles. They're in pairs. So one pair of base angles is 1 and 2. And I bring those 1 and 2 to your attention first because I want you to understand that the base angles are not their positions in the reference of how the trapezoid is like it's not the bottom angles, but it's basically two angles that rest on one of the parallel sides. So 1 and 2 rest on that top parallel side. It doesn't matter if this trapezoid is turned on its side. 1 and 2 will be a pair of base angles. In addition, 3 and 4 are a set of base angles. And then finally, the base sides are the two parallel sides. And we'll call those, it's the two parallel sides of the base sides. We'll call those B1 and B2, and it really doesn't matter which one's B1 and B2. It's just that there's two of them. Okay, with all that said, some of the properties that we need to make sure we have written in our notes and understand are trapezoids have one pair of parallel sides. Two pairs of consecutive angles are supplementary. Certainly these two are supplementary because they're two consecutive interior angles of parallel lines, right? We've done that before. Now, what I want to point out is these two and these two are not, they are definitely consecutive, but they're not supplementary. If they were, then that would force it to be a parallelogram, right? Because in a parallelogram, all the consecutive angles are supplementary. In a trapezoid, there's only two pairs of consecutive angles that are supplementary. Also, additionally, the mid-segments are parallel to the mid-segment is parallel to the base, and the mid-segment is half the sum of the length of the bases, and we'll talk more about that. Those probably right now just mean words to you, and then we'll explain those in a little bit more detail in just. So let's take those properties and do a couple of examples. Example 1, we're given that angle C is 48 and angle 1 and, or angle A and D are congruent to each other, okay? They're equal to each other. What is the measure of the other angles, okay? So we need to find out what angle A, D, and also B are, okay? So put me on pause and come back and check your work and see how you did. Keep in mind that since this is a quadrilateral, one of the important tools that we might use is that all the angles add up to 360. Put me on pause. One of the things that I would do first is find angle B. So I know that angle B, this one here, and they told me C is 48 degrees, so I'll go ahead and put that in. I know that those two angles are consecutive interior angles, and they should be supplementary. In other words, they should add up to 180. So I do that work, and I find that angle B is actually 132 degrees. That's a little too much. How about it being, yes, that's right, 132 degrees. So now we're looking at finding A and D. Now, A and D are congruent to each other as given. Okay, so there's two ways that we could do that. First of all, we know that the measure of angle A plus the measure of angle D better equal 180 degrees because those two angles by the properties should be supplementary. Just for written sake, I'm going to go ahead and since angle A and angle D are both angle measurements, I'm just going to call it the unknown M as in Morgan, and I'm just going to use that M as my unknown. And so M ends up being, or the Morgan angle as we would call it, the Morgan angle would be equal to 90 degrees. And I'm going to reserve the second way of doing that for another time. All right, let's look at another type of trapezoid. This is called the isosceles trapezoid. Like an isosceles triangle, it has two congruent sides. Okay, so what we find out is that the legs, another way of saying that the legs are congruent. Okay? Now, an isosceles trapezoid has some other properties that we'll need to put into our notes and make sure that we understand. First of all the properties of a trapezoid, a regular trapezoid, are true as well. Consecutive angles, The two consecutive angles are supplementary, um, and all the other things that we talked about earlier. But also, interesting enough, of course, the legs are congruent, but the base angles are congruent to each other. Now, I'm not saying that they're all the same angle, because if that was the case, then we'd be looking at a rectangle. Remember, all the angles inside are still 360. But what I mean is that the base angles are equal to each other. Okay, so if one's 36, the other one's 36. And then finally, we find out that the diagonals are congruent to each other. Okay, so both of those are exactly the same length. If one's 13, the other one's 13. This is very similar to a rectangle that also has diagonals congruent. So if I had a quadrilateral where I knew the diagonals were congruent, sometimes people, you don't believe it has to be a rectangle, but it also could be a trapezoid. All right, let's take a look at this problem here. Using the properties that we just zoom in on a little bit. Let's go ahead and see if we can come up with an equation to solve for that x. Okay, so one of the first things I would do is I would go ahead and write in that c is 65 degrees. Okay, so now use the properties that we've learned about trapezoids, and in this case, isosceles trapezoids, to see if you can discover what x would be. So you gotta find a way of writing an equation to solve for x. Put me on pause and come back and check your work. So I'm going to first go find b. The reason is because they're asking me to find x. That 65 and that x plus 12 don't have any known relationship yet, right? And so we don't have any property that says something about opposite angles in a trapezoid. But we do have some ideas about consecutive interior angles of like b and c. Okay, so we'll write that they're supplementary, and then we'll solve. All right, so it gives me 115 degrees. Now I do have a relationship between A and B as a known property in isosceles trapezoid, and that is that those two angles are congruent. So that allows me to write the equation x plus 12 equals 115, and of course solving that gets me that's equal to x is equal to 103. That doesn't mean that that angle is 103. Remember, that's what x is equal to. Okay. Now, if I wanted to, I could just double check. I could take that 103, stick it back in there. Of course, that equals 115. And of course, I could check to see if these are what the supplementary angle would be here. Of course, it'd be 65 because of the base angles. And then I could just add them all up and see if they actually equal 360. And if they do, then I've done my math right. All right, let's take a look at this next problem, example number 3. They tell us BD, which is a diagonal, is 12, and AC is 9x plus x. What is the x? So we're going to have to write an equation. So go ahead and put me on pause. Come back and check your work. You might want to look back at the properties to see what you know about diagonals, see if that helps you write your equation. Hopefully that didn't take you too long. Diagonals are congruent, so I set them equal to each other. And we have that equation. So basically, remember, the diagonals are these lengths, right? So they come down like this. And so each one of those is exactly the same length. So if one is 9 plus x and the other one's 12, they're going to equal each other. All right, let's move on. All right, sorry about that. So let's take a look at mid-segments. So we have a couple of I-can statements about being able to find the length of a mid-segment and things like that. So let's first of all understand what a mid-segment is. So here's a trapezoid, trapezoid A, B, C, and of course you can see which ones are parallel. I have this green dot. That represents the midpoint of BC. So go ahead and draw this figure down, and then what I would like you to do is come up with the midpoint for AD. Just eyeball it and put that point down. Okay, so there's that point. Let's call that E and F. Okay, no real reason other than they just happen to be the next letters in the alphabet. What we find is that when we draw the segment that connects those 2 points, E and F, we create a thing called a midsegment. Okay, so a midsegment is basically a segment that has the legs endpoints or midpoints as endpoints. Okay, so the legs, remember, those are the non-parallel sides, and so it takes the segment, the midsegment is a segment, takes the legs midpoints and makes it the endpoints. All right. two other properties that I want you to make sure that you understand about the midsegments is that the midsegment is parallel to the bases. Remember, the bases are represented by the sides that are parallel. Okay? And then there's a mathematical relationship between the length of the midsegment and the base 1, base 2 being added together and divided by 2. And so we'll do a problem and see if you can get that. So basically there's a mathematical expression that we're going to use. Okay, that's a formula you're going to have to memorize. Hey, with the midsegment being parallel to the bases, what that does is it allows us to know that this angle right here and this angle right here are supplementary, because they're going to now be two angles that are part of a consecutive angle pair, right? Got two parallel lines. So interesting enough, the midsegment becomes parallel. All right, so here's a problem dealing with midsegments. Okay, and so you're going to look at those properties, look at the equation, go ahead and write the equation first that was expressed in the properties. Write that equation and put the pieces in the right place, solve that equation. Put me on pause and come back and check your work. All right, so as expected, you should have expected that I was going to write the equation without any numbers in it. If you did not do that, I would highly suggest, if you're a student who's struggling with writing your equations and you're wondering why, it's because you're not following me, right? I want you to write your equations without any numbers in it every single time you go to write an equation. Then you put the information in it. That's how you're going to remember it. So if you're not doing that, just understand that's the thing that's holding you back. Okay? All right, so then I take the information, I plug it into the equation. And so what I'm going to do is I'm going to go ahead and multiply both sides by 2, right? That'll cancel out the 2 on the right. I need to take that 2 on the left and distribute it through. And with that said, I'm just going to simply solve that for x equals 3. And that's all they were asking me to do. All right, we're moving into kites now. Now, kites are quadrilaterals, four-sided figures, and they have some properties. As you can see, I have two consecutive sides that are congruent, but they're not all congruent to each other, right? And it's not opposite sides are not congruent. That's not at all. It happens to be two pairs of consecutive sides that are congruent. But most importantly, this has 0 parallel sides. All right. So here's the properties of a kite that we need to remember. Okay, 2 pairs of consecutive congruent sides. And again, I've whipped through these things. You can put it on pause, copy them down. But two pair of consecutive congruent sides. 1 pair of opposite angles that are congruent. Now, the opposite angles that are congruent are not the ones between the two sets that are congruent. Okay? It's very important that you understand this. They are the two angles in between the congruent sides. Okay, so the angles are formed by two sides that are not congruent. So 1 pair of opposite congruent angles, that's these guys right here. Okay, diagonals are perpendicular. So when I draw these diagonals, I find out that they form right angles. In other words, 90 degrees. And lastly, one of the diagonals is an angle bisector, and it's a very specific diagonal. It's not like one time in this kite it's this one or whatever. It's always the diagonal that runs down the center of it like this. And there's 2 diagonals, right? But only one of these is an angle bisector. Now I can tell by this that angle right there is bigger than that one. So I definitely know it's not that one. So the diagonal that bisects the angles is the one that starts and ends between the 2 congruent sides. Okay? So you need to be able to identify that. So the 2 congruent sides point to the angle that gets bisected by the diagonal. I know that seems like a complicated stuff, so just put me in reverse if you need to and go back and look at that. Otherwise, we're moving. Now, this particular kite is one that I'm going to use over and over in the problems below. So I've redrawn them below, but they're rather small. So if you're looking at a little device, it might be hard to see them. Okay? But this is the kite that I'm working with. All right, so go ahead and put me on pause and see if you can do this one. Given the angle A is 65 and angle B is 110, what is angle C? Okay, go ahead and put that information into that kite that I showed you earlier. Come back and check your work. All right, one of the things that I know about a kite is that angle B and angle D are congruent to each other. So I know that angle B is 110, so I went ahead and made angle D 110. So now I wrote those into my drawing. I know that every kite is a quadrilateral, and all the angles add up to be 360 degrees. So that's where this next equation comes from. 65 plus 110 and so on equals 130 or equals 36, 360 degrees. So from that I find out that angle C is 75 degrees. Now what I could do is I would check that, okay, and make sure my math is right. I could add up all those four angles and find out if indeed they are equal to 360. All right, given the slope of AC, which is a diagonal, is negative 3/4, what is the slope of BD, the other diagonal? Okay, so use the properties that you know about the diagonals above and see if you can figure out what the other slope would be. Put me on pause, come back and check your work. Okay, so we find out that the diagonals are perpendicular. That's what we know. Okay, and if they're perpendicular, what do we know about their slopes, right? We know that they're opposite reciprocals. Okay? Okay, so if they're opposite reciprocals, well, the slope of AC is negative 3/4, and the perpendicular slope to that one is what? Hopefully you said 4/3. All right. Here's the last problem. Given DAB is 70 degrees, so we need to make sure that we know how to find that. DAB is 70 degrees. What is the measure of DAC and AED? Put me on pause. Come back. Well, DAC, which is this angle, is half of the other one because that's the angle that's being bisected by the diameter or by the diagonal. So that ends up being 35. Okay? And then the other question is what is AED? That's an easier one. AED is equal to 90 degrees because the diameters or diagonals are perpendicular. Okay, hopefully that totally made sense to you. Okay, well here is your try it problems. I'm going to take the last few moments here and just scroll through it where it's in a little bit bigger format for anyone that's looking at it as a smaller device. If this is obviously viewable to you, then great. Go ahead and start working on those. We'll see you next class. All right, see you next class, everybody.